Alright, so this is video 2 about the rock cycle, and in this one I wanted to just talk about the rocks themselves, kind of the processes that form those, and I was going to show you a few examples, and then I was going to show you on some maps where you can find different types of rocks. And so let's start with the rock cycle and what forms these different types of rocks. So first we have the sedimentary rocks. The sedimentary rocks are a result of erosion and weathering that basically takes giant rocks that exist out there and plates and all that, and the wind and the rain causes it to break down into smaller and smaller particles called sediments. And those sediments are carried by the wind, and the wind takes them and it deposits it, or sometimes water through rivers and streams, and it deposits it in new locations. And wherever it deposits it, that's where you're going to find sedimentary rock layers, because it deposits it and then it goes through a process. Those sediments are deposited and it goes through this process of compaction and cementation. So compaction is kind of like what it sounds like. You take some materials and you squeeze it really, really tight together. And then cementation, just kind of like with sand. If I were to take sand and pack it together in my hand, if I let it go, it's going to fall apart still. Whereas if I take sand, squeeze it really, really tight, and then I add some kind of gluing agent in there, once I let go, it's going to stay as a solid rock. And so that's the process that sediments go through to turn into sedimentary rock, is that they get compacted as more and more stuff gets laid on top of them. And then there's minerals in all those different rocks and sediments, and as water interacts with that, it causes it to glue together, and that's the cementation part. So the compaction and cementation together actually has a scientific name, and that scientific name is lithification. So lithification is simply the scientific term for cementation and compaction combined. So here's some examples of sedimentary rock. I'm going to give you a really obvious example. So this sedimentary rock, if you actually look at it, you can see different pieces within that sedimentary rock. And it looks like that those sediments were just kind of broken down and then they were squeezed together really tightly. And then after they were squeezed together tightly, they formed and they were cemented together. It formed this sedimentary rock. But there's some other examples that don't look quite as obvious, and you'd have to look very closely to be able to see all the different sediments, because oftentimes they get packed so tight it's hard to see the sediments. So this is also a sedimentary rock. This is called fossilized limestone, I believe. And on there, if you look super, super close, you might be able to see tiny specks, but it's pretty difficult. But this is also a sedimentary rock. So I just want to show you those two examples. And then after that, we have metamorphic rock. And so metamorphic rock is whenever rock is put under extreme heat and pressure. And whenever it's put under that heat and pressure, it causes the rock to recrystallize. So it takes the crystal structures, and let's say that they're arranged like this. Well, now it's going to arrange it this way, where one particle's here and one particle's here, and it's going to squeeze it together even further, reducing the amount of space between those. And so during that process, you're going to get rock created that looks like this. So on this one, you might be able to see stripes on that. And it's kind of difficult to see, but if you see those stripes on there, that used to be sedimentary rock that was squeezed under extreme pressure, and where this used to be, maybe one of these lines came from one of these rocks that was squeezed so much that it turned into one of those single lines kind of across there, the middle, because it was squeezed so much and put under so much heat and pressure. Here's another example of a metamorphic rock. And this one, you can almost see where there's like little crystals in there. And so this one also, once again, was squeezed and it was recrystallized. Whenever it was recrystallized, it caused those crystals to actually form within that rock. And so the process of heat and pressure changes that crystal structure of the rock and turns it into a new rock. In that process, fossils would be destroyed and everything, whereas in sedimentary rock, I could find fossils. And then we have igneous rock. Igneous rock is created when any of the rock types are melted. They're melted down back into magma, and then they are cooled and they recrystallize or resolidify. So here are some examples. This one came from a volcano. So this is magma that was ejected from somewhere in the mantle. It took it a long journey. It didn't like happen in one day from the mantle all the way to the Earth's surface, but it came up through the mantle maybe over multiple years or hundreds of years, and then as it was ejected out, it cooled and it formed all these bubbles. If you can see those bubbles in there, and this is igneous rock. Notice that it's kind of like a burnt color, right? Because rock that's melted isn't going to retain the same colors of the original rock. Here's another example of some igneous rock. This rock also has crystals in it, and it has different colors in it. And this one was not ejected from a volcano. This one was uplifted from a subduction zone, and whenever it uplifted, it brought on those mountains. The mountains were going to be made of this igneous rock, because that's what's on the bottom of the crust, is this igneous rock, and it's being exposed. There's some places, there's some mountains I hiked in Texas, that as you're walking along the mountain, you find this all over the place, this igneous rock. And you could just pick it up and put it in your pocket if you wanted to, right? As long as it wasn't a national park or a state park. And so this is just kind of lying all over the place where these mountains were formed from an oceanic plate and a continental plate colliding. You can also find them where two continental plates collide, because sometimes whenever it collides, some of that stuff is brought up from the very bottom of that crust, and it's brought up and it's exposed so that people see it. All right, so those are the three different types of rocks. I want to show you on a map where you can find these different types of rocks just in one area. So this is the Grand Teton National Park. So I went there 3 summers ago. I'll probably go back this summer. Trying to figure out the best angle here. Here we go. All right, so if you look on here, this is a topographical map. You can kind of see right here, you can see these like there's river basins and there's roads that you can see, but also you see all these lines that kind of show topography. Topography is just like the surface structure of the earth there. And so this is the mountain range itself right along here. I'm trying to follow it. And then where you see the lake and all this is the valley side right here. And so you have this extremely smooth valley on this side and extremely rocky mountains on this side. And that's because you had at one point in this zone where this crust, when it was pushing together, it formed this mountain range, and it uplifted a lot of that crust, the very bottom of the crust where igneous rock is found. So along this mountain range right here, the Grand Tetons, you're going to find a lot of igneous rock. Well, on this side you have a valley, and in that valley area you can see all the water there. That's carrying sediments off the mountain, and it's depositing it down into this valley area. And so there's going to be a lot of sedimentary rock found in this. And so that's just one example of where you can find igneous rock and sedimentary rock. Also in this mountain range, because there was a lot of heat and pressure, you're going to be able to find some metamorphic rock. And I want to show you an actual picture of what those mountains look like, because they are continuing to grow and they're continuing to weather, and it's an active area. It's not like the Appalachian Mountains where it's stopped, but you can see there in the background these super sharp mountains, and a lot of that is being exposed there is igneous rock, and there's metamorphic rock mixed in there as well. And then on this side where the river is, if I were to take a picture going out the other direction, you just see this valley area, and it's an extremely beautiful area, but you would be able to find sedimentary rock in that valley area. All right, well, that's all I have for you. Look through the PowerPoint and answer as many questions as you can, and if you have more questions, feel free to ask me. Thank you.